Hi, I'm Rick Dixon. I'm an inventor. I live in Kirkland, Washington, and I've invented several renewable energy devices that have caught national attention. In 2007, I invented the piezoelectric wind tree, which was illustrated in Pure Energy website wiki, and subsequently I wrote a book called New Concepts of Renewable Energy and published it in 2008, and it was featured in that book as well. Following that, a Cornell researcher found my article, and Cornell did some independent study and confirmation of the earlier experimental results I got on the wind tree, and they are now promulgating the concept for use in buildings and in urban areas for low power wind power applications. Their paper that references my original work was published in the American Society of Mechanical Engineer Journal in September 2009. It's called Vertical Stalk Flapping Leaf Generator for Wind Harvesting. And there's a direct reference to my, and a drawing, reference to my drawing in the paper and to my book, New Concepts of Renewable Energy. I've also worked on some other energy ideas, including OPEC, which is my term for ocean pressure electric conversion, which works off pressure differentials between deep sea water and surface air pressure at sea. This concept has not been perfected yet, but I'm working on it still, and I think one day it will lead to an inexhaustible supply of renewable energy for almost the entire world, as most of the world's population lives within 200 kilometers of the oceans and deep lakes. And this energy resource is renewable. It's 24/7. It will never run out. It's out of sight, completely environmentally friendly. It's basically you can think of it as a modified Stirling engine that runs off pressure differentials, augmented by wind power. Anyway, that's in the future. I did pioneer the concept. And what I would like to talk about today, though, is a new concept that we have been working on. It's called, and it's published in a book, a small book called Toward a New Theory of Everything: Subatomic Wormholes, Space-Time, Quantum Entanglement, Relativity, and the Nature of Gravity. That was first published in December 2011 on lulu.com. And I just want to discuss the theory today. Basically, what we're saying is that the space-time matrix of the universe is in fact composed of something. Now, you may have read a recent experiment by Paul Hogan, who's trying to prove that space-time is in fact composed of something, and he thinks it's digital. The space-time is digitized. We don't follow that at all, and our theory is that space-time is composed of subatomic wormholes at the Planck unit level. And it sounds bizarre, but we have reason to believe that that is exactly the nature of the universe in terms of space-time. That's what space-time is composed of. It explains a lot of things. It allows you to explain quantum theory without a whole new set of physics laws. You can use Newtonian physics to explain quantum theory if you accept the idea of Planck unit level subatomic wormholes composing space-time. Also, I have a small demonstration of how that would work in terms of gravity. It gives a whole new explanation of gravity. Gravity currently is believed to be a universal force and a field force. We don't think it is. We think that gravity is more of an effect than an actual force. And it could also explain why they haven't been able to find the elusive graviton particle that they keep looking for in physics. In our theory, if you look at this simple tool here, which is a series of pins, these represent the subatomic wormhole nature of space-time. Although in reality, we think it would be shifting constantly. These subatomic Planck unit wormholes would be moving constantly and separated from each other by forces, possibly electromagnetic repulsion. We're not sure exactly how they're separated, but they would be separated. And what happens is if you take an object impacting space-time displaces the wormholes, as I'm showing here. That explains gravity. You see, here's the impression in space-time made by the object. For example, if this was the sun, or at the subatomic level, this was a molecule or an atom or a proton. Now, there was a professor in Brazil, I believe in 2007, Professor Santini, wrote a paper, a very interesting paper, that hinted at this whole possibility, and that he felt that the strong nuclear force, especially associated with protons, was due to the fact that protons had a connection to some sort of subatomic wormhole effect. The flip side of this, that we extrapolate, is that it would also explain inflation in the universe. So for example, if this was a large object like the sun, on the border of our universe with the adjacent universe, you would see a bulge because the wormholes would be displaced. Now this goes back to Fred Hoyle's steady state universe theory in a way. He never really accepted the Big Bang. We don't go that far. We think there may have been a Big Bang, but we also think that matter is expanding the universe and through inflation. So we kind of buy into a sort of quasi-state theory concerning expansion of the universe. We think there may have been a Big Bang, but the fact that the universe is expanding at different rates in different parts of the universe, and there's different concentrations of matter, may be due to this subatomic wormhole effect with matter displacement of the subatomic wormholes. Now, we also think that matter is being created within the universe more than it's being destroyed. And here's how I like to show that in a chart that we made. And it starts with large subatomic large black holes in outer space, which we know destroy matter, break it down into the very small units such as bosons. Some of that comes back in terms of Hawking radiation. Some of it leaves our universe and goes into an adjacent universe. We believe it diffuses back in through the boundary layer of this adjacent universe with our universe. As you see here, the space-time boundary layer is not smooth due to the inflation that I showed you as a result of matter. As this energy diffuses back in the form of very tiny low mass or no mass particles like bosons, etc., through the subatomic wormhole or Planck unit wormhole matrix, these things will break off. We believe these wormholes will break off and form strings with little boson particles activating them inside. This coincides with string theory. So those become the building blocks for matter. They become quarks, so on, subatomic particles, atoms, molecules, and eventually a gas and solid state, matter. It's an elegant theory. We don't have any proof for it at all. This is all arrived at through reasoning, syncretic reasoning, but I feel like I'm in good company. Democritus, the ancient Greek philosopher, in I believe it was 450 BC, theorized the atom. Never saw one, never could prove one existed. It wasn't until late 19th century, early 20th century that the atom was actually proved to exist. Niels Bohr, the atomic structure. We're at that same level of development. We're proposing a theory. We believe that physicists, if they examined our theory, would see the logic behind it. And if they could prove this mathematically and test it perhaps, it would confirm it. We think that it could be tested with something like the double slit quantum experiments, for example. It's one way to explain why you have this random impact on the other end of the double slits by subatomic particles. Well, if they're traveling through these shifting wormholes, they're going to hit different probabilities of hitting in different areas. So quantum theory could be very elegantly explained by this. Anyway, that's our theory. As one professor told me, without the mathematical proof, that and $1.50 will get you a small coffee at Starbucks. Thank you very much.